Algebra 2, solving three variable systems. So in Algebra 1, you learned how to solve two variable systems through substitution and elimination. We're going to need that because we're going to eventually get to that. The way to solve three equation systems is to use that elimination process you learned in Algebra 1. I want to combine or add two equations together that will have a result of one of my variables canceling out. And I need to do that twice. So I'm going to take these three equations and condense it to two equations with two variables. And then I'm going to combine those to be one equation with one variable, and then I can solve that and then kind of work backwards. So the task is, how do I get an equation that has only two variables? First thing you want to look at is, and there's the thing about these questions, what's difficult from a teacher with these questions is that when I grade this, I could have almost every student in the class give me completely different answers, and they could all be correct. There are so many different ways to go. I need a variable to cancel out when I add two equations together. But it could be x, it could be y, it could be z, it doesn't really matter. I would first look at the equations as is and ask yourself, if I add two of them together, like they are right now, will something cancel out? And if I add, these two together as is, the y's will cancel out. They are additive inverses, negative y and positive y. So if I add these two equations together right now, the y's cancel out. And that's exactly what I want to have, and I want something to cancel out. If I add these together, nothing cancels out. If I add the first and third together, nothing cancels out. So I'm going to add these together because something will cancel out. Now, what if nothing would? What if there was a 4 here and nothing would cancel out? Well, then what you need to do is you need to change one of the equations, sometimes both of the equations, through multiplication so that you can then add them and something will cancel out. But this is a gift. You want to find that gift. So take a good look at them and say, can I combine any two? Right now, something will eliminate. And the answer here is yes, I can combine these two. So if I add these two equations together, equation 1 and equation 2, I get negative 3x. The y's cancel out, so minus 2z equals 4. So that's one equation right there. I still can't solve for x or z because I have both. But what I need to do is I need to find a way to combine another two equations, either these two or these two, in such a way that the y's will cancel out. Because I don't want another equation with x and y. I want another equation with x and z to pair with this one. So whatever variable you cancel out with your first grouping, you got to make sure you do that same variable canceling out in the second grouping. And it doesn't have to be y's. I'm just doing that here because that's what this set up to be. If the z's happen to cancel on this one, well, then I'd make sure the z's cancel out on the next one. But you always want to have, I'm trying to create two equations that have the same two variables. I just created one equation with x and z. So now I want to create a second equation with x and z. So what I'm going to do is I'm going to combine these two equations together. And again, there's so many different options I could go here. I could do the first and the third, but I'm choosing to do the second and third just because I needed to make a choice. If I add these together right now, the y's will not cancel out. But I see that this is a positive 2y, a positive 1y. So if I multiply this equation by a negative 2, and I have to multiply everything by negative 2, but the y value will become negative 2y. So then I can add these together and the y values will cancel out. So I'm going to rewrite this. After a product of times negative 2 becomes 10x minus 2y plus 6z equals negative 16. And I'm going to pair that with my third equation unchanged, 3x plus 2y plus 2z equals 2. Add these together. Our result is 13x. Y's cancel out. 8z equals negative 14. And so that I'm going to pair with up here. So I'm going to bring this up here now, because now I have two equations that have two variables. Plus 8z equals negative 14. All right, so now I'm just focused on this. I have a linear system just like in Algebra 1. Two equations, two variables. I want to combine them. As it is right now, nothing will cancel out. I can figure out a way to cancel out the x's or figure out a way to cancel out the z's. And in this case, the z's are the easier way to go. If I multiply this by 4, that'll change to be negative 12x minus 8z equals 16. The reason why I did that is because I know this has a positive 8z. So now I can write this one as is, unchanged, plus 8z equals negative 14. And when I add them together, I end up with x equals 2. And that's it right there. And once I have x equals 2, once you get one answer, the dominoes tend to fall. And I actually work backwards. So I started with 3 equations, 3 variables. I created 2 equations, 2 variables. And then I combined those to be 1 equation, 1 variable. Now that I have that, I work backwards. Where do I plug in x equals 2? Well, I don't want to plug it in here into the original because then I still don't have y and z. I need to plug it into one of the equations that has 2 variables. So I go from 3 to 2 to 1, and once I get that answer, I bring it back to the one that has 2. And I really just pick any equation. Doesn't really matter which one. I can take the 13x plus 8z equals negative 14 and substitute in my value of x. X equals 2, so that's 13 times 2. That's 26 plus 8z equals negative 14. Move that for a minute. Subtract 26. 8z equals negative 40. Divide z equals negative 5. And now that I plugged into here, now I can take both my answers and plug into an original. I'll plug it into, again, pick any one you want. I'm going to take the top one here. 2x minus y plus z equals negative 4. 2x is 2 times 2, so that's 4. Minus y is what I don't know. Plus z is really plus negative 5 equals negative 4. 4 minus 5 here, which I can make a negative 1 equals negative 4. I could add 1, making it negative y equals negative 3, and I get y equals 3. And so I have x equals 2, y equals 3, z equals negative 5. I want to write my final answer as a 3-dimension coordinate, x, y, z. Just like you're used to x comma y, well, this is going to be x comma y comma z. It goes in alphabetical order. So 2, 3, and negative 5. One last thing before I'm done is I'm going to check my answer. How am I going to check it? Well, I found my third variable by plugging into my first equation. That means I have 2 equations from the original problem that I can use to check. Just pick one of them. You don't need to do this in both. Pick the one that looks the easiest. The bottom one here, 3x plus 2y plus 2z equals 2. If all goes well, when I plug in x, y, and z, I'm going to get 2. So 3x is 3 times 2. 3 times 2 is 6. 2y is 2 times 3, so that's plus 6. And 2z is 2 times negative 5, negative 10 equals 2. That's 12 minus 10 equals 2, and 2 does equal 2, so we are checked, and that's it. That's it.